Good evening to all. Myself and Arun Kumar from EC department. I'm going to talk about stability analysis. In control system, stability analysis is the one of the factor which will give the concern system will be working or not. So based on the stability only, we have to calculate the concern frequency as well as the concern route, which is focused on the S planes. Here we are going to find out how the route location has been framed by using the stability analysis. So this method can be calculated by using a Routh-Hurwitz criteria. So it can be noted as Routh stability criterion. So there are some properties which can be used in this Routh stability criterions. Based on the properties only, we have to write the concern stability factor. So the properties are, if the sign is negative means then the system may not be a stable one, because sometimes the equation may be a plus and minus values, so that the system equation will be a not, the system is not stable one. After that, the root of the concern criterion will be located in the left half of the S plane. So next one is, if the sign is not changed means then the root is a stable one, then it can be located as a right half of the S plane. So these are the two conditions and two properties of the Routh stability criterions. So these criterions, these properties will be implemented in this criterions. So before that, we are going to calculate how the root has been stable or not. It can be calculated by the following rules. Initially, the roots has been framed by S power n. Suppose if you are having n is 5 value means S power 5, and the next value is S power 5 minus 1, 4 and 3, 2, like that the value will be comes up to the S power 0. And here the A0, A2, A4 and all variables, it is followed by odd and even variables. Initially it will be taken as a even variable, A0, A2, A4, A6, like that they are calculating, and next value will be odd variable, A1, A3, A5, A7 and A9. So all the values, all the variables has been framed by using the above principles. So next we will see how the values has been assigned by equations. So, and this is the one of the problem which will be asked in this Routh-Hurwitz criterion. The problems are, as initially they are given about s power 4 and 8 s cube and 18 s square and 16s plus 5. So based on the properties, we have to write the first thing. Initially we have to take the root value s power 4, the root highest root value is 4, so that we have to take s power 4, and next value is s power n minus 1, s power 3, and the next remaining value will be s power 2, s power 1 and s power 0. So like that the same variables has been assigned by even and odd variables. Initially we have to take s power 4 and s power square, and next one is s power 1. So like that we have to write one, first one is 1, and next one is 18, and next one will be a 5. So like that the odd values will be written as 18, 8 and 16. If the values are maximum divided by the same value means we have to divide by the concern value. So here they are taking the s power 3 value as divided by 8, so that the equation and the corresponding value has been changed as 1 and 2. Because if the numbers are very low means we will get some low values, low measurements, and the calculation also very easy. So that I have chosen as 8 and 16 will be divided by 8, so that we will get some less values, 1 and 2. So after the problem, next step will be s power 2. The s power 2 will be calculated by the some calculation. So initially the calculation will be made by 1 into 18, 1 into 18 minus 2 into 1, 2 into 1, and next list value 1. The same will be repeated for the other value also. 1 into 5, 1 into 5 minus, here doesn't have any value, so 0 into 1, 0 into 1 divided by the same value 1. So after calculating all the values, we have to write the concerned value for the next row. For example, we will get s power 2 as 16 and 5, so we have to write 16 and 5. After that, we have to calculate the same corresponding value for the next row, s power 1. The s power 1 value can be calculated by the same properties, same problems. 16 into 2 minus is a common for all the two terminals. 16 into 2 minus 5 into 1 divided by 16, so that the next value will be notified in the next column. So the value will be 1.7. The 1.7 can be indicated in a s power 1 value 1.7. So like that, all the values has been arranged and calculated up to the last end. The last will be s power 0, because 0 means it doesn't have any root value. So until the last value, we have to calculate whether the sign has been changed or any other parameters will be displayed. So next value 1.7 into 5 minus 0 doesn't have any value in the next column. So 0 into 16 divided by 1.7, the final value will be 5. So we will get 5 value. All the values are in positive manner. So if the values are positive, means plane will be the plane will be considered as a stable one, because it doesn't have any changes, and the values are in positive only. So the plane will be acted in a right half of the s plane. So like that, all the problems has been calculated by using the first column. And if the sign has been changed, or if the values are changed, then then the plane will be a unstable one, and if the sign is changed, means it will be located as a left half of the s plane. Thank you.